So welcome to the next topic, chemical tests. So in this particular topic, we're going to describe the tests for. So these are the tests for aqueous cations. Essentially what you're doing is.
Hi guys, this video is going to cover flame tests and precipitation reactions, and we'll end with a summary.
The compounds of certain metals will burn with characteristic colours, and this is why flame tests can be really useful in order to identify particular metal positive ions or cations. Flame tests are really simple to carry out. A small sample of the substance is placed into the flame of a Bunsen burner, and the colour of the flame will change from pale blue to the distinctive colour for the metal ion. There are a few examples and characteristic colours that you'll just need to remember for your exam. The lithium ion, Li+, which burns with a crimson flame. The sodium ion, Na+, which burns with a yellow flame. The potassium ion, K+, which burns with a lilac flame, which is also the lilac flame that you'll see in a reaction between potassium and water. Calcium ions, Ca2+, will burn with an orange-red flame. And finally, copper ions, Cu2+, will burn with a distinctive green flame. If the substance that you're testing contains more than one metal ion, the flame colour may be masked or mixed. So therefore, flame tests only work for samples that contain a single metal ion. But in these cases can be a very simple and conclusive test. Another set of useful tests is based on precipitation reactions. These are possible due to the fact that many metal hydroxides are insoluble and will therefore precipitate out of a solution when they are formed. Precipitate just means that they will form a solid and come out of the solution. A key exception to the rule that metal hydroxides are insoluble are the group 1 hydroxides. For example, NaOH or KOH, which are both soluble. The insoluble metal hydroxides form precipitates with characteristic colours. This diagram just shows the formation of a precipitate, which is floating on top of a solution. In order to form the insoluble metal hydroxides, a few drops of sodium hydroxide, NaOH, is added to the solution of the substance that is being tested. In this table, we can see an example of some of the commonly found metal ions, as well as the colour of the precipitate formed on addition of sodium hydroxide. All of the metal ions listed on the left-hand side of the table are positively charged, or cations. And the notation used just has the charge on the ion in brackets. For example, calcium with 2 written in brackets can also just be written as Ca2+. An iron with 3 in brackets can just be written as Fe3+. The first thing to notice is that the insoluble metal hydroxides of calcium 2+, aluminium 3+, and magnesium 2+ are all white.
Hi guys! To continue watching this video and unlock hundreds of other super concise and exam board specific GCSE Chemistry and Combined Science videos, just click on the Snap Revise smiley face. Join me today and together let's make Chemistry at GCSE a walk in the park.
So in terms of flame tests, this is how you carry out the flame. So in terms of flame tests, you have to know the different colours. So in terms of now testing aqueous anions, so in terms of testing for halides, getting a little bit more in depth, the first thing you did in that table on the previous slide was add dilute nitric acid and then add dilute silver nitrate solution to the sample. Okay, so different coloured precipitates form depending on the halide, and you've got to know the different numbers, the different colours. Okay, so general equation is that the silver ion in solution, aqueous solution, plus the halide in aqueous solution forms the silver halide solid, and that is basically a swap and drop to form AgX, where X is the halide. The nitrate ion acts as something called a spectator ion, which we've already looked at previously. Doesn't change during the reaction, so you don't need to put it into any ionic equations. And here are the different ionic equations. So for the chloride ion, you get a white precipitate of silver chloride. For the bromide ion, you get a darker, creamy precipitate of silver bromide. And for iodide, you get a pale yellow precipitate of silver iodide. And there's
Hi guys! In this video we're going to be looking at the tests for carbonate ions, halide ions and sulfate ions, before finishing off with a summary.
We can start by thinking about the test for the carbonate ion, or the CO3 2- ion. This test is based upon the fact that when a carbonate reacts with an acid, salt, water and carbon dioxide are all produced. For example, if sodium carbonate reacts with 2 molecules of hydrochloric acid, the products will be 2 molecules of sodium chloride salt, as well as carbon dioxide and water. And here we have a carbonate and an acid reacting together to give us our salt. We can remove the spectator sodium and chloride ions from this equation and look at the ionic equation. So this is simply that a carbonate ion reacts with two H+ ions from an acid in order to give carbon dioxide and water. And this ionic equation will hold regardless of what carbonate and what acid are used in the reaction.
Hi guys! To continue watching this video and unlock hundreds of other super concise and exam board specific GCSE Chemistry and Combined Science videos, just click on the Snap Revised smiley face. Join me today and together let's make Chemistry at GCSE a walk in the park.
Another really useful test is the test for halide ions. These are negatively charged ions formed by the halogens, such as chloride, iodide and bromide ions. In order to test for these, dilute nitric acid and silver nitrate are used. Dilute nitric acid has the chemical formula HNO3 and is aqueous, whereas silver nitrate is AgNO3, also aqueous. The first step in the test is to add nitric acid to the substance. This makes sure any carbonate ions that are present have been removed. As we saw on the last slide, carbonate ions will react with acid in order to produce salt, carbon dioxide and water. The next step is to add silver nitrate, which will react with the halide ions in order to give characteristic precipitates for each ion. In this table you can see the halide ion as well as the colour of the precipitate given after the reaction with silver nitrate. If chloride ions are present, the precipitate will be white. If bromide ions are present, the precipitate will be cream. And if it's iodide ions that are present, the precipitate will be yellow. In each case, silver cations Ag+ are reacting with the halide ion in order to form an insoluble salt. And it's these salts which we see as the precipitates formed in the reaction. From the ionic reactions, you can see that in each case, two aqueous ions are combining together in order to form the solid insoluble salt. This reaction was carried out with silver nitrate, but the nitrate ions are spectator ions in this reaction. This means that they remain the same before and after the reaction and don't take part in it at all. Only the silver part of silver nitrate reacts with the halide ions.
Hi guys! To continue watching this video and unlock hundreds of other super concise and exam board specific GCSE Chemistry and Combined Science videos, just click on the Snap Revised smiley face. Join me today and together let's make Chemistry at GCSE a walk in the park.
So in terms of testing for gases, these are all the gases that you can test for. So ammonia, as we've just probably seen in the second or third slide here of testing for cations, turns damp red litmus paper blue because ammonia is a base. Carbon dioxide turns lime water milky white due to the formation of calcium carbonate. Chlorine turns damp blue litmus paper basically white, which is called bleaching. Okay, like bleaching your hair white. Hydrogen, squeaky pop test, so a lighted splint, loud pop. And oxygen is a glowing splint where the splint relights, which you've probably already done as well. Okay, so the next slide is a video kind of reinforcing these ideas.
In this lesson, we will learn how to test for the presence of hydrogen, oxygen.
In this lesson, we will learn how to test for the presence of hydrogen, oxygen, carbon dioxide, ammonia, and chlorine. We test for gases in the laboratory because it is nearly impossible to determine the identity of a gas just by its appearance. As an example, hydrogen, oxygen, and carbon dioxide are all colorless and odorless. How would we be able to determine which is which? To test for hydrogen, place a lit splint at the mouth of the reaction vessel. You should hear a very distinctive squeaky pop, which confirms its presence. This is due to the combustion reaction of hydrogen in the presence of oxygen, creating water as the only product. To test for oxygen, place a glowing splint at the mouth of the reaction vessel. Keep in mind that the splint should be glowing, not lit. A glowing splint relights in the presence of oxygen. Why does hydrogen burn with a squeaky pop? Why does oxygen relight the glowing splint? Hint, recall some properties of hydrogen and oxygen. Please pause the lesson to think about this and resume once you are done. Hydrogen is highly flammable, and the pop sound that you hear is actually a mini explosion. The glowing splint relights in the presence of oxygen as there is a higher concentration of oxygen in the reaction vessel than compared with air, which is only 21% oxygen. Carbon dioxide will extinguish a lit splint, but the same occurs in the presence of ammonia. A more accurate test is to bubble carbon dioxide through lime water, which is an aqueous solution of calcium hydroxide, also known as slaked lime. Lime water turns milky in the presence of carbon dioxide due to the formation of calcium carbonate. Ammonia extinguishes a lit splint and turns damp red litmus paper blue. In the presence of concentrated hydrochloric acid, a white smoke will form. This is ammonium chloride and confirms the presence of ammonia. Chlorine turns damp blue litmus paper red and eventually bleaches it to white. In conclusion, hydrogen burns with a squeaky pop, oxygen relights a glowing splint, and carbon dioxide turns lime water milky. Ammonia turns damp red litmus paper blue and forms a white smoke of ammonium chloride in the presence of concentrated hydrochloric acid. Chlorine turns damp blue litmus paper red and continues to bleach it to white.
So the final aspect of this topic that you have to be aware of.
Hi guys, in this video we're going to be working through an exam style question.
Hi guys, in this video we're going to be looking at an exam style question about the chemical tests for different ions. The question starts by asking you which of the following gives the correct test and result for potassium ions. And you're told to circle one test and one result out of the following options. On the left hand side we have 3 different tests and we have 4 different results on the right hand side. Let's start by looking at the tests. On the left hand side we have flame test, reaction with sodium hydroxide and reaction with barium chloride. If you're familiar with the test for ions, you might remember that the reaction with barium chloride is used as the test for sulfate ions, as the reaction between barium chloride and sulfate ions produces the insoluble precipitate barium sulfate. You'll also need to remember that both flame tests and the reaction with sodium hydroxide can be used in order to identify metal cations. The reaction with sodium hydroxide works when it produces an insoluble metal hydroxide with a characteristic colour. In the case of potassium, we know that the exception to the rule that metal hydroxides are insoluble is for the group 1 metal hydroxides. Sodium hydroxide and potassium hydroxide are both soluble and therefore won't produce characteristic precipitates. What this means is that in order to identify potassium ions, we need to use a flame test. So this is the answer for which test we need to use. You're also going to need to remember the characteristic colours of some common metal ions. For example, if you put a compound containing potassium into a flame, the flame will turn lilac, and this is therefore the answer for the result we'd expect if we carry out a flame test with a substance containing potassium ions. This question is worth 2 marks, so you'll get 1 mark for getting the test right and 1 mark for getting the result right. We're then asked to explain why this test could not be used to identify potassium ions in a solution of potassium sodium chloride, and we're given the chemical formula KNaCl2. The important thing to note here is that potassium sodium chloride contains two metal ions, both potassium and sodium ions. Sodium ions will turn the flame yellow, and this will make it difficult to identify the other metal ion present. This illustrates a general point about flame tests.
Hi guys! To continue watching this video and unlock hundreds of other super concise and exam board specific GCSE Chemistry and Combined Science videos, just click on the Snap Revise smiley face. Join me today and together let's make Chemistry at GCSE a walk in the park.